Welcome back. I'm Ahmed Mahmoud from DataMind AI, and this session is part of the CI/CD in Snowflake series. And today we are going to talk about the setup in GitHub for Snowflake. We have seen yesterday we created the key pairs for use from using our laptop, and then before that we have set up the dev UAT and prod environment in Snowflake. And also we have configured Snowflake for GitHub integration, and we link them Snowflake with GitHub. So now is we are going to see how to set up a GitHub for Snowflake for our purpose before we dive into the implementation side of the CI/CD. Now, let me go to GitHub to show you what I have created so far. Yeah, and in GitHub, I have a GitHub account here. Yeah, so if you go to GitHub, of course, as we always do in here, um, you can create your yeah, let me start from the beginning here, repository. If you click on the repository and then you click new, and then in here you choose the account here, or yeah, your GitHub uh, account, as it were, and then you choose this one, who the owner of that one is, and then you put the name of the repository, and eventually you can say create. Of course, as you can see here, you can choose between public and private, but we are going to do it public now. And also you can add a README file, but I'm going to push the README file from my folder. So for example, if you're working in Visual Studio Code in your laptop and creating different kind of SQL script to do your work, it could be like ETL processing using SQL or Python, or it could be any kind of, for example, any kind of SQL script to help you, for example, monitor data quality, or it could be modeling as well. So it could be any kind of SQL where you want to do monitoring, version control in it, and you need to also you want to collaborate with the team. So you do everything in your Visual Studio or any IDE of your choice. I do it in Visual Studio, and then you do some work there. So I put the README file there as well as like instruction on how people do. So you do create here anyway. So just to make it simple, the key part is like you choose the owner, yeah, and then you give it a name and the create. So once you do that one, once you do the create part of it, so I have done NHS NE Snowflake CI/CD. So because I have created like dummy and any patient, and I'm going to look on the quality of the data on that one. The liberty, I put like some quality issue there, so to give us like access to the data quality there as well. So if you click in here, of course, you can hear, so you can see all the files which I put there. I just push it to GitHub. But for your case, what if you want to do your work from your laptop? What you do is like you can go to code here, copy this one, and clone it in your laptop. Yeah. But I will show you how to push it as well. That is what you're going to do first. So, but if you want to do work from this one, so all the codes are here, and we are going to, you can use, come here and copy, clone it in your laptop and work it there. Yeah, so now let me go to my laptop to show you how I pushed this one. And say for example, what I have done is like I have created like a folder to work with. Yeah, a my if you go to C drive here, for example, I created this folder, Snowflake CI/CD demo, and then within that folder I created the similar name to help me push it, yeah, to the repo. So I double click this one here, for example, and then you can copy this one, yeah, and then go add to CMD. You open CMD as admin, And on that one, what you do is you just cd to that folder. Can you see? This is the one I showed you just now. And if you cd and paste it here, and then you are going to work on that folder. That's the key part. This is the first part. Now we are on this folder. So we first though we need to put we need to put it like a Git on top of that, version control, whatever it is inside here. And then we need to commit this our Git or the version controlling, yeah. And then we, after we have done that bit, then we can push it to GitHub. So first though we have done this bit, so we need to do initialize the Git in that folder. So you see Git init will initialize Git in this folder. If you don't have like an account, it will ask you username and password. Of course, you need to provide those ones. So for me, because I have already created those username and password, it's not asking me anything. So just Git init, it will be initialize it, and then it is empty. Yeah. So now what you do, like now it is controlled by Git now, the folder. So I want to see whether I can access the remote, which is GitHub. Yeah, if it's a git remote dash v, it give me nothing. So I don't have currently an access to my remote. So what you can do is like you can go to git remote add origin. This is the one. This is the command git remote add origin, and then you put all the URL from GitHub. Yeah, this is the one I said you can download, copy, clone, as it were. Yeah, so you can copy and git clone and paste this one, and it will clone for you. But in here we are just adding it to the our git here. So git remote add this one. So we are going to work on this one, of course. And now if you say git remote dash v now, you can see it showed us this is the origin, like for fetch and push. Yeah. So it gave us these two. Now everything is working fine now. And then we need to go to this versioning of our files. So what we will do is like we need to add everything. Yeah. Everything which is inside. So git add dot, as you can see, once you do this one, it is going to add all the files into the git side of it. And then if you say what is the status, it will say on branch master, which is the same as main, but no commit yet. So this is been added, but it has not been committed yet. If it is on IDE in Visual, so it will say A, it's been added, but you need to commit that one. So to commit your changes, so you say git commit -m, and you need to give it this name, initial commit. I give it any name of your choice so that you can trace it in GitHub as well. So once you commit that one, so it will commit it, and then you can push. It's a git branch. Where's the main? Yeah. So our branch is main. This is very important. And then we push it to that main. Yeah. So we put it is main. Now have access to the main. So git push you origin. Origin is, as I said before, is here. We say it is origin here. Yeah. Add origin to this place. Yeah. So it's going to add it in that place. And I think that is the last bit of git. So it starts with git init, and it will end like git push. You push your you push it to GitHub. Yeah, this is the last exercise. So we push it this way. So once I have done that bit, if we go here, you can see whatever you have pushed it in here. So before I go any further, I want you to focus into important things, because this file or this folder, there's two important folders here. The admin is a separate one, and the .github is another one, which help you like the process. but we have these two. I'll focus first on these two. The migration is the one you put your code, your SQL script. So all your SQL script in here, create a table, generate data, and then data quality rules and so on. So whatever you can have like a multitude of lists here, the SQL script, you put it in this migration folder. This is one. The second bit is the schema change. This is like it controls the change, especially of the objects. Say Snowflake, they call like their tables, their views, their tasks, and streams. All this stuff is called objects using Snowflake. And if you want to version control and see the changes when it's happening, so if you add something and then you want to see when you have added it and then what version it is now, and then you have if you have updated it, if you do something on it, so it will track the changes for that one. So this schema change is like it controls the objects while they're being created, and it will put every changes in the history, yeah, so that to be audited at a later stage. So this is the engine, call it the engine of the one we are doing. Don't forget, what we are going to do is like we have dev, we are going to move it to UAT and then to production. So this process requires like of course it's going to be through pull request, but the process of moving them and then putting all the changes as they go as they move, yeah, it should be tracked here. And this schema change is the one it is but this is a tool. We will see it. You need to be install it while you do the deployment side. You need to install the tool. It is like lightweight software, as it were, which helps, like for example, do this mainly to database management, as it were, yeah, or data management control. So any changes to the database with objects in Snowflake will be captured here and controlled through this tool. Now, and of course, this is the code I said, and this one, the admin, is basically when you yesterday, for example, when you went to Snowflake and created those databases, schema, warehouses, users, and also the rules, and we granted everything. So we're using a code, and therefore those codes, if you need them, they are sitting here, yeah, and you can see it is here, yeah. So you can have access to them, you can play with them, you can copy it and then create in Snowflake if you have access, and create those important starting point, yeah. So this is for the admin. It's not part of the CI/CD, but the CI/CD, these two, and then you have these two, the script, and I'm going to come back to the script later on, but the workflow is the key part here. And also I'm going to come back to this validate YAML. This is extra bit which I put, but the key part is like the deployment here. The deploy YAML file is, as you can see, it will change when you do like pull request from dev. First, you create a feature, of course. From feature, it will go to dev, from dev to UAT, from UAT to prod. Yeah. So you write your code in dev. In feature, you create the features you want to have. For example, new SQL script. Yeah, or new code, as it were. Python, it could be Python code as well. So this is the future, and then once you are happy, you can push it to dev. And from dev, again, if people are happy, it can be pushed using the pull request to UAT, so that to be tested. And also when everyone is happy, this testing to be signed off, and then it will be approved to go to prod, as it were. Yeah. So this is the process we are going to follow, and this is the code which is going to do it. Yeah. So so again, the deployment is going to be run in Juventus machine, virtual machine. This is part of the YAML file here. You specify the machine here as well, and the environment here, of course, once the running here is start from this side, and then of course everything you need for example, Python code, you are going to use 3.11, for example, the Python code. You need to be careful here because sometimes this version will create a problem for you. So it should be the right version or for some work. But again, I mean, this is from experience. 3.1 is the stable one. It works for everything. But sometimes 3.1, 11 might not be enough or not good. So you can change it as well. So this is the one I was talking about just now. You need to do pip install this Schemachange. Yeah, this is the software I was talking about. You need to do that one, and then you need to do the secrets. You need to take it off and then put it somewhere to work on it. And then this is the environment variable which we are going to create just now in here. And once you create that one, we'll come back to this one, of course. You are going to write history. As you can see, this is a place where we are instructing the Schemachange to deploy and go to this migration and put the history here. So this is the deployment side, which we are going to look at it just after we set up this environment variable. Now, I want to show you how this one is set up here. These folders before we move them to before we start working in Snowflake. So that is one area. So another important bit which we are going to do is to set up this environment variables or secrets they call them. So don't forget we need to set up the dev, UAT and prod as well here as branches and which mirrors the database we created in Snowflake. We created dev, UAT, and prod in Snowflake as databases, and also we put schema for each of them. So and in here on our script here, we are going to create the tables which is required, and then we are going to populate the data just as an exercise. Yeah, that's what you're going to do. Now, if you can see here on the top, you have this menu. There's a couple of them here, but the key part is the settings. So if you work in an organization, sometimes they don't give you access to this one because there's a lot of issues, a lot of things which if you are not comfortable or if you are not like an expert on this matter, the IT, your IT might not give you, or the DevOps team might not give you access to that one. So you need to ask them, if you are working organization, you need to ask them to give you access to the setting, because without that one, we cannot do the work we are going to do now. So either they need to do it for you on your behalf, but I think the best one would be to do it yourself and to request for access. So this is a setting here, which is a key element. So the setting, it has a couple of them, but which we are not going to go through that one. Probably as we go along, we might do one or two here. But for now, we are interested in this environment setting here. Environment. This is the key part. You remember last time when we connect the Snowflake to GitHub, what we have done is we have created like a token, and we went through the token. We went through a process here. We went to the profile and then developer, and then we created the token from there, and we copied that token and put it as a password in Snowflake. And this is a different thing we're doing here. So now to create the environment and secrets here, we have two choices basically. Let me show you the first choice, which I have done, and then we'll come back to this one. So to create the environment here, as you can see, this branches. Yeah, you have the main, because this is now is in the main, and then you have branches here. So the branch here, you can create the branch from here. So you can say new branch here, put a name dev, for example. It will be based on main, create new branch. That's what I have done here. Yeah. So it has an advantage, of course. It will put everything which was on main on that dev environment. Yeah. So a copy, as it were. So that's what I have done from main to dev, and then I have created this UAT the prod. Yeah. So this is one area. That's that one way of doing it. Yeah. And the second way, the second part to do it is through this via this environment variable, the one I was showing you. Come here, environment, and you can do like new environment. You put the name, configure the environment as it were, and that's it. So dev, one U81, one prod. Now, once this is created through the way you have done it, of course, and then you click, if you click here, one, for example, this one, dev, yeah, so it gives you, this is the control mechanism. If you want to say, for example, require the reviewer before pushing it to dev, you can say, I want this one, and then give the person who will be the reviewer, yeah. And then also, if you want to protect the branch, yeah, if you say, for example, if this is not, I mean, protection means like if this does not happen, if this happens, then like for example, move the data or move the process to this. If it didn't happen, then block it, kind of thing. Yeah. So this is the restriction you need to put. These two are very important, especially when you do, for example, when you deploy them to production. Before that, it depends on your team. If you have well-structured team, you have a lead and then people beneath him. So the lead will always want to review first and then approve. Once you approve it, and then you can move from dev to production and so on. Now, the one we are going to do here is like this, these secrets, they call them environment secrets. Yeah. So we have 7 of them. One is the Snowflake account. Yeah. So this one, of course, the Snowflake account, you need to provide. You need to provide it. So what I have done is like, if you go to your Snowflake here, and what you can do is like you need to find like the current account and the region, for example. Yeah. So if you run this one, it will give you, yeah, the current account is this one, this name, and the region is Azure UK South. Yeah. And also I found like this one is also very useful. If you go to this one, for example, view details, it will tell you, yeah, the account locator, the cloud platform, the edition, and also yeah, and then if you see here, there's this a SQL command, so it will give you. You can copy this one, for example, to see the current organization name dash current account and so on. Yeah, so that's very useful. Um, I think information here, so you can copy, and if you can say the current database, the current users, current schema, the current role, yeah, locator name, and so on and so forth. This is also very useful. You can access it from here, as I said, just from here, and then this is the account, which yeah, and then view, yeah, and see it here as well. So this is one area where you set you find your account and region to provide in Snowflake. Yeah, so you can either use this one, or also you can go to the documentation for Snowflake documentation, and it will tell you how to find this current account and current region. And once you've done that bit, what I have done is, for example, for mine, because the list is long and is a bit confusing as well, I put them into a list here. So I have this notepad. So it's not a Snowflake account. This is the account, and then you need to do dot UK South dot Azure. This is the format you need to provide. And then for the Snowflake user CI/CD, so I listed them here, including the private key as that, and then I came here to add them one by one. Yeah. So that's the best way to do it, I think. So the Snowflake account, you go here. So what you do is like click here, you say Snowflake account, and paste the value here. And the same thing here, for example, Snowflake database, yeah, add, and you add the database in Snowflake. The private key, this is the one we have created from our laptop, RSA one. So you need to copy the private key in here. We've seen yesterday the public key. we've done it in Snowflake, and the private key. You need to come here and put it here, and then you have the role, the schema, the user, the warehouse. So all this stuff, this is, don't forget, for UAT, yeah, for the dev, sorry, for the dev. So you put everything here, and then you go and do the same thing for UAT, yeah, for UAT as well. There should be 7 of them, yeah, and then for the production as well, the same thing for the production. Now, the production have a slightly different setting, because, as I said, we need to get it. You need to have like a control, a gate to allow and not allow kind of thing, yeah, like a gate of a building. So that's what we do here. So we have 2 gates here. One is a reviewer. It requires a reviewer. If you see, if you require a reviewer, and then you can put your name here. Or alternatively, what you do is like, also another one is like a protection, yeah. So protection branch only, so you can protect the branch, yeah. And protect means like you allow certain things, and if that is not met, then you block, yeah. So it's a big topic in the GitHub, and yeah, I can, so you can go and read about it. But again, this is a control mechanism where you say um, which one is allowed and which one is allowed, yeah. So you can configure out, for example, which user should do like the push in, the pull request, and which user is not allowed even, yeah. So all this stuff you can do it through this protection mechanism of the branch. Now you put for these 3 environments here. I think this is an important, this is the one we have done now. Now if you go to back to the uh, to, to here. So if you go to .github, yeah, you have this workflow, and this is where you, as I was showing before, yeah, deployment here. This is the one we're talking about. So in here, you specify, yeah, using the secrets, the Snowflake account, secret, the Snowflake user, all the one which you've done there. So you need to provide it here in the code, and therefore the GitHub can pick it up from there, and when it accesses the database Snowflake, it can use the right one. So if it didn't work for you, there is no connection, there is nothing, access denied, and so on. You need to look here, because this is pain, one of the pain point in this CI/CD side, yeah, because it is manual copying, pasting, trying to find that, and so on. You can forget a letter, a something like that. So you need to be careful of this one, because it creates havoc for you. If you set them up, then it will be easy to do that. Now, the last one is this one. You can see here change history table, and then create change history. So all the transaction, everything which is happening through this one, the schema change will put it into audit, log it for you, and then you can see the version today, for example. If it does today, yeah, and then if you give the same thing tomorrow, it will know that it have done it. But if when tomorrow, if this is different one, different from what you have given it today, then it will uh, work on it. So it will not create duplication. That is the key part. So as you work on your CI/CD, it will only then just identify the change which will be made and act upon them. So that's the important bit. Now I have these 2 extra bit for control, because don't forget, we are talking about NHS data, and it is like controlled, and it is patient data which is very secure within the NHS, and therefore we need to do a lot of guardrails, yeah, to guard the data, yeah, or the system. Say, for example, if you have an AA, we don't want, for example, someone to drop a table, to drop the database here, even in different places, but in this side, dropping means like we are talking about patient safety. So that's we need to put a lot of guards here, and then also our script, if they are not done properly, if they are not written properly, the SQL script. So then instead of just bringing errors and creating a problem for you, beforehand, what you do is like you need to check this is Snowflake. It has certain way of doing Snowflake SQL, and therefore your code should be like based on Snowflake SQL. So that is what it had been implemented. I am going to spend a bit of time on this too because I think this is again another extra bit which I have added here to help you control the flow of information and safeguard this. Now, let me go to this one. So what we are doing is like, don't forget our structure is dev UAT prod, yeah? So when we try to move data from dev to UAT, for example, you need to have like pull request, yeah? You do the pull request, people probably can review them, see what the changes are, approve them, and then it will be pushed automatically. Now, before you push them though, you need to validate what is being moved, yeah? So even though this pull request, okay, but you need to validation here, and also the script, also the SQL script should also be looked at, yeah, for any unnecessary issues. So this is like this is called automated SQL linting, yeah, SQL linting, like to check with the flavor, Snowflake flavor, SQL flavor, for example, yeah. So this is called linting, SQL linting with the SQLFluff, and then this is to prevent destructive statement detection, like drop table, yeah, update this and so on and so forth. So just this is for the SQL, and also branch protection gates, completing your NHS grade pipeline. This is a key part. So we have SQL guard, linting, and also branching protection. And what you get is at the end of it, NHS grade CI/CD pipeline. Yeah? Now, the PR validation, which is pull request. The PR here is pull request. So the workflow, what happens? How does we implement it into our system? So first, how it is triggered? Yeah. So when you saw, for example, the PR validate YAML file, there is a trigger there. So on pull request, this is the pull request. Yeah. Now on pull request, what you do is like if it looks like the pull request is from dev to UAT or UAT to prod, yeah. So which means it runs on every pull request targeting these branches, yeah, targeting dev, UAT, and prod, yeah. So every pull request will be targeted here. This is a trigger, yeah. So it will have two checks, yeah. Before doing the merge, it will do two kind of checks, yeah. One check is SQL fluff, yeah, which is SQL linter validation, which is like keyword casting, formatting, indentation, and the Snowflake syntax, yeah. So if it fails, the PR will not the pull request, the merge will not happen, yeah. So which means if this means if it fails the pull request on any violation, then it will stop, yeah. It will not allow you to merge it to UAT, for example, yeah. Now this is like keyword cases as a formatting, a Snowflake dialect language as well, yeah. So this is the check-in. It's called like a SQLFluff. The second one, which is also another important one, is SQL guard, which is custom Python script scans. So there is a script, the Python script. This one scans on all the SQL files you created, yeah, like the files in the migration. So all the files within the migration folder for destructive DDL, yeah, and unsafe DML as well. So it requires, for example, if you want to drop a table or create a table, you need explicit override available for this one. Yeah, so it's very important that if there is drop table, update without where, for example, truncate, all this one will be checked with this code. There is a Python code. Yeah. So it's an open source code. You can find it and use it. That's what I have done. So it's an open source code. It's Python code to check for you on the SQL, and then checks all DDL, and unsafe DML. And then if there is one, yeah, it will the merge will not happen. So this is the validation workflow. These two will be checked, and then if you don't pass, you don't. There is no merge. Yeah. So either check fails, so PR cannot, or pull request cannot merge, yeah, with the protection enabled, of course, yeah. So that's one of the area. So in here, for example, yeah. So we, as I said before, we start with the feature. So in, for example, in Snowflake, in your workspace environment, you write a code, new code, change, of course, and then you need to push it to dev. Yeah, that's the key part. So validation is required. You need to validate when you do that, and it catches any issues early. This is the starting point. So if there is any issue, it will be catched here, and then from dev to UAT, also validate before UAT, and then from UAT to prod. Yeah, this is the final get before prod. Yeah, and then you have another feature to feature as well, not a protection branch, of course. So you don't need to do that one, feature to frame. But the validation will happen from feature to dev, and from this to environment. This is the one, and then what happens is like it starts from, if you say the deployment, the deploy YAML file, it will say it starts from there. So the action checkout at v4, this one will pull your repo into the runner. Yeah, so that's what the starting point. So the repo will be put into the runner. Yeah, yeah. So it fetches the branch being merged. So subsequent steps can scan the SQL files. Yeah, so this is the starting point, and then after that, what happens is like there is a script which says install, yeah, the SQL fluff, pip install SQLFluff. So installs the Snowflake dialect SQL linter here. So this is a key part. So SQLFluff is a fully open source, again, SQL linter that supports the Snowflake dialect natively. So it checks like any syntax which Microsoft or Snowflake is saying to do, and if it doesn't pass, then there is no merge. That's the key for us. So number 3 is linked SQL file. So what you do is like you go to SQL. You have installed, or people install SQLFluff, and then now you are using it. So you can say SQLFluff lint migration. The migration is the folder. Don't forget, that's the folder you are doing, and then the dialect you are using now is Snowflake. So what you do is like check all the SQL in the migration, yeah, and then for example, select is capital, and if you put it select small letters, will say no, you need to put it in capital. That is a requirement. And then formatting consistently, and indentation, if the indentation is required, it also fails. So you need to put the indentation. If there's any missing commas, any syntax Snowflake syntax issues, it will also identify it for you. So this is step number 3, and step number 4 is run SQL guard. This is a Python. It lives in .github secrets, which I wanted to show you before. It's called SQL underscore guard.py, and also it goes to the migration as well, and it checks for destructive SQL scanner. Yeah, that's the one we took before. The custom governance script detects dangerous DDL and unsafe DML patterns. Yeah. So that's again, this is I thought it was very useful to know this one. So the SQL guard will do, for example, destructive DDLs like drop database, drop schema, drop table, truncate table, alter table, create or replace a database, or create or replace a schema, risk DML, data modification without scope, yeah, and so on and so forth. This is the one is going to look for you. And if there's an issue on that one, if you don't do explicitly say, I want to drop the table, then it will fail. The merge will not happen if that is the case. And this is the script how the detection happens. It uses like uh, like a regular expression, yeah. So it uses a lot of regular expression. As you can see, it checks whether there was no where, for example, where clause is not added, yeah, when you want to truncate something, or you want to for example update something, yeah. When you want to update something, it should be there is a where clause. So if there is without where, for example, then it won't allow you to do. So now, before you do though, what you do is like this script. What it will do, it will remove all inline and block comments. Yeah, so that so some people might think clever, they can hide this the drop table in within this comment, and therefore to avoid this kind of exercise, what it does is like first it remove all comments, which means the comments are not important for your script, and therefore it remove them before it does this the guardian side of it. Yeah, so the detection pipeline, it's just the step by step is like it read the SQL file first. Yeah, there is, if you see on the code, it will say row path.read text, yeah, and then reads the entire content of each the SQL migration, and then it will strip the comment, as we said before. This is the second step, and then in step number 3, there will be like a regular expression pattern, and then step number 4 is statement level DML check. Huh? That's how it does it, and this is the script is in here as well. So I'm not going to go through this script one by one. You can see it into if you go to GitHub here, the one I was showing you before. If you come here, for example, and this is the script lives here, so it is here, yeah. So that is how it does it. You can read how it is done here if you are interested on them. But I thought here is very important to show you what you can do with your pipeline, how to protect your pipeline as well. So that's one area which I thought very useful. So if you want to override, because say for example, if you want to, yeah, say you want to drop a table. So again, you have this is the on the output, and the overriding mechanism is in here, and then the key part here is like everything will be git history capture. It will be captured there, and the always should be explicit and not implicit. Yeah, so the allow kind of thing should also be the SQLFluff configuration. This is very useful because especially if you have an error, sometimes you don't know what to do. Say for example, when I was working here, I found out that there is like one line which was it had been obsolete now. They are not using it, and therefore, if that is the case, then you need to come here to this code and then see how it is done here. Yeah, so I will show you what this problem is. It's here. Maximum line length 120. They said this one is depreciated now, and you need to change it in your code. So you can come here and change that one. As you can see here, this one, for example, this is the one. The rules maximum length is 120. Either you can comment it or you can add another one if you want to. So that's why the importance comes here. The capitalization, and then the from, or, where, or join, all these the SQL items you need to be in capital here. So there's no dialect. There's also another one which is very important: this qualify, flatten, lateral, join, and variant types. These are Snowflake specific, and then it will check for you as well. So that's the beauty of this check-in, and your code should be good quality. Your code is always, your code should be good, as well as your people should not go inside your code and do some harm on your pipeline. So what happens, like if a developer, for example, done some drop table, so the pull request is opened, targeting dev, and then GitHub Action will do like pull request validation workflow, triggers automatically, and then the SQLFluff will say pass it because everything is in a capital. Drop table is valid SQL syntax, and then the SQL guard here say it fails drop table, pattern detected, and therefore there is a drop table which is dangerous one, and therefore merges is blocked. Yeah, so you go there, you just you change it, you change that one, the failure, the drop table, and then you go to developer. Now it says create or replace the table, and you can create a select from CTE one here, for example, and instead of dropping, he will do another one, replace the safe alternative, and then again the pull request updated, validated, rerun, SQLFluff pass, and then the SQL guard also there is no destructive pattern recognized, and then the merge happens. So that is what is going to happen. So in the nutshell, the complete governance. This is again as this is the one I put in this CI/CD, and the one I'm trying to help you do this bit is like this a governance stack. Yeah, so your pipeline should be well governed as well. So we have brought here the SQLFluff, which is code quality and syntax consistency. This is that what it protects for you, and when it runs on every PR before merge, it why it matters, because it gives you clean standardized SQL, easier code reviews, no style arguments in pull request. So this is the SQLFluff, and then they have the SQL guard as well. This is automatic, yeah, data safety and blast radius containment on every PR before merge. And this one prevents accidental destruction of NHS data, explicit override, auditable intent as well. So you have the branch protection, the one we saw before. So check enforcement, it will enforce governance as well. Always cannot be bypassed by developers. Ensures uh, like like CL checks are not optional. No direct pushes to dev to UAT, yeah, or to prod, yeah. And then the required reviewer, the one we said before on the prod, the prod is only prod you need a reviewer. Change control for production, UAT to prod PR only. Human approval gate meets cap level governance without heavyweight ITSM, yeah. And you have the RSA key authentication, identity and access security at every Snowflake connection. So passwordless, auditable, environment scored, no credentials in CL logs. Yeah. Now the last one is list privileged roles and users as well. So data access is minimization, always role level enforcement, even if credentials leak, attacker can only reach one environment schema, NHS DSP toolkit aligned. So these are like a key part. It is aligned with the policy of the organization, especially for NHS. Yeah. So that's why I say NHS great, because there's a lot of policy which guards the data within the NHS, and therefore that's why I felt it very useful to put them within the pipeline so that you protect, yeah, all the ones. So what we saw is like just we automated SQL linting, destructive change detection, auditable override, code review, mandatory production approval, full audit trial, password a authorization, and list privileges. So if you are going to map it to the organization, say for example the automated SQL linting, it is SQLFluff enforces Snowflake syntax and style on every PR, which is you have a good quality script. Yeah. So the destructive change detection is SQL guards blocks, drop, truncate, update without where, and then the auditable override allows destructive creates explicit git trace intent. Yeah. So the code review is branch protection requiring peer review on the PR, and then the mandatory prod approval is GitHub environment required reviewer, which is change governance, for example. So full audit trail, Git history, and GitHub action logs, Snowflake access history. So this is the one we're talking about, the full audit. You remember we put this into the code. So you have Git history, you have GitHub action logs, you have a Snowflake access history as well. So the password authentication is RSA key pair. We saw it yesterday, how it is created and how useful they are. And it is done per environment, so no credentials in CL logs. Now, list privilege roles, which is each CL user scope to its own environment only, so NHS DSP aligned. So these are the key part, the governance side. That's why we say our pipeline is going to be NHS grade. Yeah. So that's I think probably a bit long, but I hope it was very useful for you. I hope also you have learned something out of it, and I hope you can use it in your production level. So next time, what you are going to do is like we are going to use it practically. So we are going to use, for example, we go to Snowflake and yeah, link the two together. How we can move from Snowflake to GitHub and how to do the pull request. It might not work here and there, but we are going to resolve them as we go along. So thank you for listening. See you next. Bye for now.